Welcome back to the session of module 2. In the previous part of the class, we have discussed what is the nature or the factors to be considered for the designing of the sievers, and we have also discussed the formulas pertaining to the designing of the sievers. Either it may be varying from the Chassis equations, Manning's equations, Kutter's equations, all those allied equations along with the Heisenberg equation we have also come across for it. And in this today's part of the class, let us get to solve two sorts of the problems. One in which the data has been given in order to find out what is the combined siever flow rate, and in another set of the problem you will be going to given only three datas. What are those? Let us get to know one by one when we solve the problem. Okay. Now look upon for the problem. Design a combined siever of a circular section to serve a particular area using the following data. Observe it carefully. Area to be served is 120 hectares. 120 hectares. Intensity of rainfall is 50 millimeter per hour. Coefficient of area is 0.5. Population 1,20,000. Rate of water supply 135 LPCD. Peak factor 2.25. N is equal to 0.013 and S is equal to 1 in 750. In addition to this, another statement given, the siever is to run 80% full at peak discharge. Okay. Now let us get to solve the problems. First, let us get to note down what are the given data. Given data, combined siever of a circular section. So the siever to be designed, it is in a circular section, and it is which kind? Combined siever. Next, second one. Area to be served is 120 hectares. So therefore area is equal to 120 hectares. 120 hectares. And next, intensity of the rainfall is being given. Intensity of the rainfall is 50 mm per hour. So I is equal to 50 mm per hour. Next, coefficient of area is being given. So K is being given, that is equal to 0.5. Next, the population is being given. Population, it is 1,20,000. 1,20,000. Rate of water supply 135 LPCD. So per capita is equal to 135 LPCD. Next, you also have a peak factor. Given peak factor is equal to 2.25. Next, given N is roughness coefficient, 8th one, roughness coefficient is equal to 0.013. And slope is being given, 9th one, S is equal to 1 in 750. In addition to that, it is given that the siever is running 80% full. So the siever runs 80% full condition. Okay. Now let us get to solve the problem. There are two critical steps. One is to determine what is the combined flow, and then at the 80% flow conditions, what is the diameter of the pipe that has to be provided in regard to the area. So this is the problem. If you wanted to go for any of the designing considerations, Let us get to solve it. Okay. Step 1, determine combined flow. Determine combined flow. Okay, combined type of the sewers, it imparts both storm water as well as the municipal wastewater arising from the residential or from the commercial activities. First one is, whatever the data given here, it is mainly related to determining what is the storm water runoff, that we call it as the wet weather flow is also to be taken into consideration, and the dry weather flow also. Now, first let us go for determining. First one is determine dry weather flow. Determine dry weather flow. For determining the dry weather flow in terms of an wastewater, we know that average daily demand of water, or maybe the maximum daily demand, we have maximum daily demand of water is equal to peak factor into average daily demand. Average daily demand. Now, this average daily demand is nothing but the peak factor is being given here is 2.25. So 2.25 into what is the average daily demand is population into per capita demand. So therefore population into per capita demand. So that is equal to 2.25 into population is 1,20,000 into per capita is 135 liters per capita per day. Now this is one thing. I want in terms of a meter cube per second. The result has to be always expressed in terms of meter cube per second. So therefore this particular sort of the population where we have in terms of in liters per day has to be converted in terms of a meter cube per second. So therefore for that conversion you have the factors to convert liter into meter cube, 1000, because 1000 liters makes 1 meter cube, into 24 into 60 into 60. Okay, this particular sort of an answer, if you go for multiplying with 0.8, you're going to get it as the maximum discharge, that is maximum dry weather flow, that is equal to 0.8 times of the maximum daily demand, because 80% of the water is converted in terms of an wastewater. When I add all those things, let me carry out here also. Same thing if it is multiplied by 0.8. So what happens if you can compute it? So 2.25 into, or let me take it as like this, 1.8 into whatever the things which is being here, 2.25 into 1,20,000 into 135 divided by 1000 into 24, converting in terms of in 60 minutes and 60 seconds, you'll be going to get in terms of in meter cube per second. The answer, if you compute with your using your calculator multiplied by 0.8, tends to give you the value of 3375. 0.3375 meter cube per second. This is dry weather flow. Now, I want to determine what is the wet weather flow. Therefore, wet weather flow is equal to, that is Q wet weather flow is K into I into A divided by 360, where area is in terms of an hectares. All those things conversion is taken by with this rational formula. Therefore, area is 120 hectares, I is being given, K is being given. So, all this datas are taken up. So, therefore, what is the value of the K here? It is, it can also be taken as a capital. K is equal to 0.5 into I is intensity of the rainfall given as 50 millimeter per hour, 50, and the area is being given as 120 hectares divided by 360. That mm per hour, as well as here you come across in the case of the hectares, when it is being converted, that particular factor you get in terms of in meter cube per second. Meter cube per second. This wet weather flow tends to give you 8.67 meter cube per second. Sorry, 8.33 meter cube per second. This is the wet weather flow rate. Now, I wanted to go for combining the flow rate. What is the combined flow? Because the sewer is in a combined condition. Let me take upon for this side. Only 3 datas are left out. Let us get to know. So, combined flow rate is equal to the sum of dry weather flow and wet weather flow. So, combined dry weather flow is given as 0.3375 plus 8.33 meter cube per second. So, 8.33 and here 0.3375, roughly you go for getting it in terms as 8.67 meter cube per second. This is the Q combined sewer flow rate. So, if this is the condition, read out the problem carefully. The sewer is to run 80% of the full at the peak discharge. Peak discharge is only, it is this. So, in this particular sort, it has to run only 80% of the full. 80% of the full conditions, what about that? Let us get to know. Next step is to determine the dimension, because when you are designing for the sewers, you need to determine what is the diameter of the circular sewer. Now, step 2, determine the diameter of circular sewer. Circular sewer. This is step 2. Now, what they have given, whatever the discharge which is taken, it is the peak is running 80% of the full conditions. Okay, that is equal to 0.8. We know that from the continuity equations, Q is equal to A into V. Substitute here, that is 0.8 into A into V. Okay, now here area I wanted to find out what it is, and as well as what is the velocity also. This is the Q peak which is being given, the value here it is being given. I wanted to find out what is the area. Area is given as pi by 4 into d square. This is the normal part. 80% of the running full condition, and in this they have told that whatever the wetted perimeter comes across are so to be taken into consideration. And what about the formula for determining V? We know that V is equal to 1 by n r to the power of 2 by 3 and s to the power of 1 by 2. And what is r is equal to? R is equal to A divided by P. R is equal to A by P. Now let me substitute, and if you call this as equation star, we need to substitute it and then later on get it back. What is the formula for this? Later we need to substitute it. Now for this sake, I am going to rub this part. R is equal to A by P is being given. When R is equal to A by P, what is area is equal to? Pi d square by 4. What is the perimeter that you have? Perimeter for a circular one, it is nothing but it is equal to circumference nothing but pi into d. So therefore pi into d, upon the cross multiplication you are going to get it as d by 4. R is equal to d by 4. Now what happens here? So this particular thing you need to take the equation, substitute all those things. So therefore Q peak is equal to how much it is? 0.8, because 80% running. Area is being given as pi by 4 into d square, pi by 4 d square into what is the V is equal to? We have the Manning's formula, that is 1 by n r to the power of 2 by 3 s to the power of 1 by 2. Again, for your simplification, I am writing one more step to understand what is the value of the n is being given as 0.013. R is nothing but A by P, that is d by 4 whole raised to the power of 2 by 3, and S is what given? Slope as 1 in 750. You can take it as 750, 1 by 750 whole raised to the power of 1 by 2. So Q peak is nothing but the combined portion. So Q peak is nothing but the combined portion of the sieve. Earlier what we have taken for the consideration of the peak discharge, so therefore what it is? 8.67. Only term which is unknown is to find out what is the value of the D. Let me simplify furthermore, that is equal to 0.8 into pi into d square into d to the power of 2 by 3. In the denominator you have 4 into 0.013 into 4 to the power of 2 by 3. So 4 to the power of 2 by 3, I am segregating it in the denominator, it is 2 by 3 is 0.66. It will be easy for you. And into 750, 1 here into square root of 1 is 1 itself only, isn't it? So therefore next is 750 whole raised to the power of 0.5. That is equal to 8.67. Furthermore, when you simplify this, so d square and d to the power of 2 by 3, a to the power of n and a to the power of n, apply the law of exponential, so a power m plus n, therefore leading to d to the power of 8 by 3. I wanted to take the d to the power 8 by 3 itself only towards this step, so therefore d to the power of 8 by 3 is equal to whatever the things, multiply it and get the solution for it. So d power 8 by 3 is equal to 8.67, taking back to this 8.67 into 4 into 0.013 into 4 to the power of 0.66 into 750 raised to the power of 0.5 divided by what is the thing that left in the numerator? It is 0.8 into pi. So this is the d to the power of 8 by 3. Next, what happens? I wanted to know what is the value for this. So for this, simplify it and the d will be whole raised to the power of 3 by 8. This is how you are going to get the equation. This is not like a normal quadratic equation. It is the decimal part has also been left, so therefore you can solve either through using your calculator in the equation mode, and finally you are going to get the answer. Okay. So therefore d is equal to what is the value that you have substituted. You can either go for calculating it. So 8.67 into 4 into 0.013 and 4 to the power of 0.66 and 750 whole raised to the power of 0.5, or I can take it as in terms, if I wanted to take it as in terms of an d itself only, whatever the value that you are going to get it, same thing, whole raised to the power of 3 by 8. So therefore d is equal to 2.57 meters. Okay, d is equal to 2.57 meters. When I found out the value of the diameter of the circular sieve, the next set of the condition is I can able to determine what is the area also, isn't it? If I know what is the area, therefore I can find out what is the velocity also. So this set of an equation is very much important. So let us get to know. So area is equal to, we have it as pi by 4 into d square. So what is that pi by 4 into d square value is pi by 4 into 2.57 the whole square. You will be going to get it as in terms of a meter square, and the area to be considered is in terms of an 80%. So therefore it's a multiplicable factor of 0.8. What is the answer that you are going to get it? Into 0.8 divided by 4. It is 1.32. Area is 1.32. Similarly, find out what is the velocity. V is equal to, either you can go for using even the continuity equations here also to find out what is the V or the Manning's equation. So 1 divided by 0.013 into, what is that? R is equal to A by P, that is D by 4. So remember here the concepts, D by 4. So that is 2.57 by 4 whole raised to the power of 2 by 3. And what is the value of that? S is equal to, that is 1 by 750. This equation you can going to use it, and velocity is expressed in terms of an meter per second. Getting the point clear for this? So therefore the velocity is being given as 2.083 meter per second. 2.083 meter per second. So altogether you have find out what is the combined part of the sievage and determining the diameter of the circular sieve. So this is the problem to be solved whenever asked in the examination. Clear with this? Now moving on to the next set of the problem. Before moving on, you need to see that whenever this kind of an equation arises to determine the unknown part of the D, carefully you need to go for the substitution, take it back onto the LHS side, and whatever the known terms, take it onto the RHS side and get to know the equation. Okay, I think it is clear for you people. Now let us move on to the next set of, okay, I hope you have understood the problem. We shall continue in the next itself only. Thank you.